This is the first of two modules on a really important concept in mathematics and programming, namely that of functions. Functions in mathematics is a concept you've been familiar with for years. There, a function is really a rule that assigns to each input value a corresponding output value. A function is defined by simply specifying its rule unambiguously for all possible values of the input. Here, a function named f transforms an input value x by squaring it to produce the output value f of x equal x squared. X is the input value and f of x is the output value. Of course, renaming the function and using a different symbol to unambiguously describe the rule doesn't change the function. Here, instead of using x to describe the function, the symbol y was used, and the function name has been changed from f to g. Nevertheless, this represents the same function. Functions can also have many inputs and produce many outputs by just specifying multiple rules. Here's a function with 3 input values that produces 2 output values via the mathematical rules specified here. Now let's focus on functions in programming and recall the scenario put forth earlier. I've got a complex task whose solution I know can be reused in multiple independent instances. What do I need to do? Well, I need to write the instructions for that task, the calculations, the loops, the conditionals, all the programming constructs we've been learning over the last several modules, in a way that they work properly on any valid input values, and I need to store that in some sort of reusable function file. Let's take an example we're familiar with. For instance, the trigonometric cosine function. Maybe an algorithmic expert has written down the instructions using a power series expansion with known rates of convergence, which results in a set of instructions that accurately compute the cosine of any given angle. We're fortunate that people have already done that for us, and we use the cosine function without thinking about it in our calculators and in Matlab. Then, to execute the task, it's only necessary to call this reusable function to carry out its general instructions on the specific data at hand. This modularity helps us break down a large complex task into a collection of smaller tasks. Each of these are individually easier to understand, to design, to write the solutions for, to debug, and to maintain and improve. That's why functions are so important and are one manner in which we deal with the complexity of the problems that we're about to learn how to solve. Functions are a main part of almost all programming languages, although they may have different names. In Matlab, they'll be called functions. In other programming languages, they might be called methods, subroutines, procedures, and so on.